So how do we take the secant, cosecant, and cotangent in the unit circle? In order to understand that, you're going to have to understand how to take the cosine, sine, and tangent in the unit circle as we talked about before. If you understand that, it's going to be pretty simple. First thing you got to understand is that the reciprocal of cosine is what? Secant, right? The reciprocal of sine is going to be cosecant. Reciprocal of tangent is going to be cotangent. If you remember those, it's going to be easier. If you don't know that, it's going to be kind of hard, right? So reciprocal of cosine is secant, and we know cosine of theta is equal to x over r in a circle, unit circle or not. But if we're in the unit circle, we know cosine of theta simplifies to x, right? Because the radius is 1 in the unit circle, right? So x over 1 is going to be x. So cosine of theta equals x. So therefore, if we know that secant and cosine are reciprocals, what's the reciprocal of x? Reciprocal of x is 1 over x, right? Because x over 1 is x. Reciprocal of x over 1 is 1 over x. So if we know that cosine of theta is equal to x in the unit circle, then we know secant of theta is equal to 1 over x in the unit circle, right? So next is sine. What's the reciprocal of sine? Cosecant, right? So sine of theta is equal to y in the unit circle. So what's the reciprocal of y? 1 over y. So therefore, cosecant of theta is equal to 1 over y, right? Okay? So then finally, what's the reciprocal of tangent? Hopefully it's easy to remember. Cotangent. So the reciprocal of y over x is what? X over y, right? So cotangent of theta is equal to x over y. And I guess I forgot to mention, what does reciprocal mean? Reciprocal means you switch the numerator and denominator, right? So reciprocal of x is 1 over x. Reciprocal of y is 1 over y. Reciprocal of y over x is x over y. Reciprocal means you switch the numerator and denominator. You switch the top and bottom number in the fraction. Okay? So we can apply this now, right? So there's actually two different ways to find the secant, cosecant, cotangent in the unit circle. You can either memorize these rules here, right? Or you can just say, I know that cosine of theta is equal to x in the unit circle. So if I can find cosine of 0, happens to be 1, reciprocal of 1 is 1, right? So therefore I know secant of theta, secant of 0 degrees is equal to 1, right? Or you could say, well, secant of 0 I know is going to be 1 over the x value, right? So secant of 0, 1 over the x value is 1, so 1 over 1 is 1. So secant of 0 is equal to 1. So either way, you get the same answer, and you're kind of basically doing the same thing. But whatever's easier for you to remember, just do it that way, right? So let's do a couple more examples. So let's say secant of pi over 2, right? So secant of pi over 2, let's say, what's cosine of pi over 2? Well, cosine of pi over 2 is going to be 0, right? But I know secant is a reciprocal of cosine. So the reciprocal of 0 is going to be 1 over 0. 1 over 0 is undefined. Therefore, I know that secant of pi over 2 is undefined, right? Or you could follow this rule and just say, if I remember secant of theta is equal to 1 over x, what's the x value here at pi over 2? It's 0. 1 over 0, undefined. Can't divide by 0, it's undefined. So either way, secant of pi over 2 or secant of 90 is going to be undefined, right? Okay, let's try secant of pi, right? Can you tell me what that is? So cosine of pi is -1. What's the reciprocal of -1? It's still -1, right? So secant of pi is -1. But what if we do it using this rule, right? So the x value there is -1. 1 divided by -1 is -1. So secant of pi is still equal to -1. It's -1 either way, right? So let's do secant of 270, secant of 3 pi over 2, right? So to me, cosine of 3 pi over 2 is 0, reciprocal of 0 is undefined. So secant of 3 pi over 2 is undefined. But if you use this rule, it's the same thing. You plug in 0 there, it's undefined. So secant of 3 pi over 2 is undefined, right? Okay, so let's do a slightly harder one. Let's try secant of pi over 4. So secant of pi over 4, I basically look at the x value, which is rad 2 over 2, and I take the reciprocal. So what's the reciprocal of rad 2 over 2? It's 2 over rad 2, but you would need to rationalize that. So to rationalize 2 over rad 2, you would get, if we do that, times rad 2 over rad 2, we get 2 rad 2 over 2, which simplifies to essentially rad 2. So the secant of pi over 4 is actually rad 2. But it's going to be helpful if you remember, where did we get the rad 2 over 2 from? It actually came from 1 over rad 2. What's the reciprocal of 1 over rad 2? Rad 2. So the reciprocal of rad 2 over 2 is actually just rad 2, if you can remember that rad 2 over 2 is the same as 1 over rad 2, right? Otherwise, you're going to have to rationalize and do it this way, which is a little longer, but you still get the same answer, right? Okay? So secant of pi over 4 is rad 2, okay? So what about secant of 3 pi over 4? So secant of 3 pi over 4, I look at the x value, take the reciprocal. So like I mentioned before, if I take the reciprocal of this, it's going to end up being negative rad 2. So secant of 3 pi over 4 is going to be negative rad 2, right? Or you can use this rule, which will end up being 1 over negative rad 2 over 2. If you know how to divide fractions, that will become negative 2 over rad 2, and then you got to rationalize it just like I did here. But eventually you would get negative rad 2. So secant of 3 pi over 4 would end up being negative rad 2. Okay? And what about secant of 5 pi over 4? Secant of pi over 4, what's the x value? It's negative rad 2 over 2, which is actually the same as this one. So actually, the secant of 3 pi over 4 and the secant of 5 pi over 4 are the same. It's going to be negative rad 2, right? So what if we did secant of 7 pi over 4, right? Secant of 7 pi over 4, what's the x value here? Rad 2 over 2. Reciprocal of rad 2 over 2 is rad 2. So secant of 7 pi over 4 is going to be rad 2, right? So we did all the 45s, right? So let's try secant of pi over 6. Secant of pi over 6, I look at the x value, take the reciprocal. Reciprocal of this is 2 over rad 3. If I rationalize that, that would become 2 rad 3 over 3. So the secant of pi over 6 is 2 rad 3 over 3, if we rationalize that. Okay? So what about secant of pi over 3? Secant of pi over 3, the x value is 1/2, reciprocal of 1/2 is 2. So secant of pi over 3 is equal to 2, right? So let's jump over to secant of 5 pi over 6. So what is the x value? Negative rad 3 over 2. Reciprocal of that is going to be negative 2 over rad 3, which becomes negative 2 rad 3 over 3, right? So secant of 5 pi over 6 would be negative 2 rad 3 over 3, right? So what if we did secant of 4 pi over 3? So the x value here would be negative 1/2. Reciprocal of negative 1/2 is going to be negative 2. So secant of 4 pi over 3 is going to be negative 2, right? So hopefully you follow that pattern. So those are the secants, right? So now we'll try to do cosecant, right? So remember, cosecant is a reciprocal of sine, which means you can either do 1 over the y value or just find the sine and take the reciprocal, right? So let's do cosecant of 0. Cosecant of 0, 0 degrees. The y value is 0. So the reciprocal of 0 is 1 over 0, which is undefined. So cosecant of 0 is going to be undefined, right? Or you can use this formula and say, what's the y value here? 0. 1 over 0 is undefined. So cosecant of 0 degrees or 0 radians is going to be undefined either way, right? So what if I have cosecant of 45, right? Cosecant of 45, I look at the y value, rad 2 over 2. Reciprocal of that is going to end up being rad 2. So remember, rad 2 over 2 is the same as 1 over rad 2. Reciprocal of 1 over rad 2 is rad 2 over 1, which is just rad 2. So cosecant of pi over 4 is equal to rad 2, right? So what about cosecant of 3 pi over 4? It's the same y values over here. So actually cosecant of 3 pi over 4 is also going to be positive rad 2, right? So what about cosecant of 5 pi over 4? So the y value here would be negative rad 2 over 2. The reciprocal of negative rad 2 over 2 is going to be negative rad 2. So cosecant of 5 pi over 4 is going to be negative rad 2. And so what about cosecant of 7 pi over 4, right? Well, that's the same y value as this one. So if cosecant over here is going to be negative rad 2 over 2, cosecant of 7 pi over 4 is also going to be negative rad 2, right? I think I said negative rad 2 over 2. I meant negative rad 2. So this is negative rad 2 as well, okay? So cosecant of 5 pi over 4 is negative rad 2, and cosecant of 7 pi over 4 is also going to be negative rad 2 because they have the same y values, all right? So let's do some harder ones. Cosecant of pi over 6. What's the y value? Y value is 1/2. What's the reciprocal 1/2? 2. Therefore, cosecant of cosecant of pi over 6 is going to be equal to 2, right? It's pretty simple. But again, you could use this rule if you want. If you think that's easier, what's the y value here? 1/2. What's 1 divided by 1/2? 1 divided by 1/2 is 2. So cosecant of pi over 6 is going to be 2. So if you're going to do it this way, you really got to be comfortable with your fractions. I mean, you got to be comfortable with your fractions either way. But taking the reciprocal of this is probably going to be easier than doing 1 divided by 1/2, right? But you still get the same answer, okay? So cosecant of pi over 3. So the y value is rad 3 over 2. Reciprocal of that's 2 over rad 3. If you rationalize, that becomes 2 rad 3 over 3. So cosecant of pi over 3 should be 2 rad 3 over 3, right? Okay, so how about cosecant of 5 pi over 6, right? So y value is 1/2. Reciprocal of 1/2 is 2. So cosecant of 5 pi over 6 is 2. Simple, right? What about cosecant of 11 pi over 6? What's the y value here? Y value here is going to be negative 1/2. Reciprocal of negative 1/2 is going to be negative 2, right? So cosecant 11 pi over 6 is going to be negative 2, all right? So hopefully you understand the cosecant ones. You know what, let's do one more cosecant one. What if we did cosecant of 3 pi over 2? Cosecant of 3 pi over 2, the y value is negative 1. Reciprocal of negative 1 is actually going to be negative 1. Or you could plug it in here. 1 divided by negative 1 is negative 1. So cosecant of 3 pi over 2 is negative 1. Okay? So that takes care of secant and cosecant. How about cotangent? So remember, cotangent is reciprocal of tangent. So cotangent is going to be x over y, not y over x, right? So it's a cotangent of 0 radians. Cotangent of 0 radians is going to be x1 over y, 0. 1 divided by 0, undefined. Cotangent of 0 is undefined. So you can either take the reciprocal of tangent. Tangent would be 0 over 1. Tangent of 0 is equal to 0. Reciprocal of 0 is 1 over 0. So cotangent of 0 is going to be undefined. Hopefully that made sense. Otherwise, you can just use this formula. It's pretty simple. So how about cotangent of pi over 2? Cotangent of pi over 2. That's going to be x value 0 divided by the y value 1. 0 divided by 1 is going to be 0. So cotangent of pi over 2 is equal to 0, right? Or you can think, what's tangent of pi over 2? Tangent of pi over 2 is 1 over 0, which is undefined. So you need to understand that if you take the reciprocal of something that's undefined, it's actually going to be 0. So tangent of pi over 2 is undefined, therefore cotangent of pi over 2 is actually going to be 0. Because why was tangent of pi over 2 undefined is because it was 1 over 0. What's the reciprocal of 1 over 0? 0 over 1. So cotangent of pi over 2 is 0 over 1, which is equal to 0. Right? Hope you followed that. So what about cotangent of pi? Cotangent of pi is going to be x negative 1 divided by 0, so that's going to be undefined, right? Okay, but the tangent of pi here would be 0, right? So then, actually, did I do that right? Tangent is y over x. Yeah, tangent of pi here is going to be 0, so cotangent is going to be undefined, okay? So what about cotangent of 3 pi over 2? So that's going to be 0, because 0 divided by negative 1 is 0. So cotangent of 3 pi over 2 is going to be 0. Okay? So let's do some harder ones. So cotangent. How about cotangent of pi over 4? So cotangent is going to be x over y. So notice that these two x and y values are the same. So if you do x divided by y, it's going to be 1, right? Rad 2 over 2 divided by rad 2 over 2 is still going to be 1, right? So cotangent of pi over 4 is going to be 1. Just like tangent of pi over 4 is going to be 1. Because if tangent of pi over 4 is 1, reciprocal of 1 is 1. So cotangent of pi over 4 is also going to be 1. Okay? So what about cotangent of 3 pi over 4? Right? X divided by y. Those two values are the same, except this is negative, that's positive. So this divided by this, x divided by y, is going to be negative 1. So cotangent of 3 pi over 4 is negative 1. Right? How about cotangent of 5 pi over 4? Well, both of these coordinates are negative, right? So negative divided by negative is positive, so I know the answer is positive either way. And I know these coordinates are the same. Negative rad 2 over 2, negative rad 2 over 2, because it's the partner point with this guy and this guy. So cotangent of 5 pi over 4 is going to be positive 1. And just like the tangent of 5 pi over 4 is going to be positive 1, reciprocal of 1 is 1, cotangent of 5 pi over 4 is going to be 1. Okay? So let's do cotangent of 7 pi over 4. I hope you figured that out. That should be negative 1, because the x value is positive and the y value is negative. Same values, just one's positive, one's negative. So cotangent of 7 pi over 4 is going to be negative 1, right? So we'll do kind of the last round of difficult ones. So we'll do the 30, 60s, right? So what about cotangent of pi over 6? Cotangent of pi over 6, that's going to be rad 3 over 2 divided by 1/2. Notice that these two have the same denominator, right? They basically cancel each other out. So you're left with rad 3 divided by 1. Rad 3 divided by 1 is just rad 3. So cotangent of pi over 6 is equal to rad 3, right? If you want to do it the other way, you want to think, okay, tangent of pi over 6 is going to be 1 over rad 3. Again, because the denominators cancel out. Well, what's the reciprocal of 1 over rad 3? Rad 3. So tangent of pi over 6 is 1 over rad 3. Therefore, cotangent of pi over 6 is going to be rad 3. Okay, that's how that works. Either that, or you can just use this rule here, right? Whoops, that should definitely be a theta, not a 0. Okay, theta, theta, theta. Okay? So how about cotangent of pi over 3? Cotangent of pi over 3, that's going to be this x divided by y, but remember the 2's basically cancel each other out. We're left with 1 over rad 3. Cotangent of pi over 3 is 1 over rad 3. So if you rationalize that, that would become rad 3 over 3. So cotangent of pi over 3 is going to be rad 3 over 3, right? If you want to do it the other way, if you think, okay, what's tangent of pi over 3? Tangent of pi over 3 is going to be rad 3 over 1, or just rad 3. Reciprocal of rad 3 is 1 over rad 3. If you rationalize 1 over rad 3, you get rad 3 over 3. So therefore, again, cotangent of pi over 3 is going to be rad 3 over 3. Okay? So what about cotangent of 5 pi over 6? Cotangent of 5 pi over 6, right? It's going to be x divided by y. So you tell me, hopefully you said negative rad 3. So cotangent of 5 pi over 6 is going to be negative rad 3, because this divided by this, the 2's cancel out. You basically get negative rad 3 over 1 is, of course, negative rad 3. So cotangent of 5 pi over 6 is going to be negative rad 3. Okay? So then let's do cotangent of 4 pi over 3. Can you tell me the cotangent of 4 pi over 3? So that's going to end up being positive or negative? It's going to be positive. So cotangent of 4 pi over 3 is going to be positive, and it's going to be positive rad 3 over 3. Now how do I know that? Because I look at this point. This point is the partner point, right? So x over y, the 2's cancel out, 1 over rad 3. I know it's positive. If you rationalize 1 over rad 3, it's rad 3 over 3. So cotangent of 4 pi over 3 should be rad 3 over 3. Okay? So what do we did? Cotangent of 11 pi over 6. Cotangent of 11 pi over 6, again, is going to be the x divided by the y. So that will end up being, let's see, negative rad 3. So cotangent 11 pi over 6 should be negative rad 3, because I look at this partner point, I do this divided by this, which is rad 3. And of course I know this is positive negative, so this would be negative rad 3, because the x value is positive and the y value is negative. That's why I know it's negative. So cotangent 11 pi over 6 should be negative rad 3. Okay, so hopefully you understood that. Again, if you understand the cosine, sine, and tangent in a unit circle, finding the secant, cosecant, and cotangent is going to be relatively easy, because these are just reciprocals of each other, right? You can just take the cosine of any of these angles and take the reciprocal, or you can try to memorize these rules, which are not too bad, right? Either way you do it, you're going to get the right answer. And remember, practice makes perfect. So if you just practice this a few times, then it's going to become relatively easy, okay? If you follow all that, give yourself a pat on the back. It was a lot of mental gymnastics, but good job.